Hello everyone, this is Lakshmi Ganesh Bavaraju. I welcome you all to our YouTube channel Vector X Academy. So on our YouTube series Aswadhama 1.0, we have already covered kinematics. Now it's our time to cover Newton's laws of motion. So entire Newton's laws of motion will be covered in 5 videos. The 5 videos contains various topics. So the first video is based on catenary, the second video is based on questions on springs and impulse, the third video is based on friction and block on block problems, and then fourth or fifth video, like we are going to have 4 or 5 videos based on the content. So there are going to be pulley problems and constraints and general problems. So if you see all these 5 videos, I can assure that your Newton laws of motion for JEE Advanced is done. So I'm going to bring the best content possible with the best questions in the upcoming videos. So today in this video we are going to cover catenary. So what do you mean by catenary? This is a concept in which is generally not taught in classes, but yet it's important because it keeps on coming in various tests. So catenary is nothing but, for suppose, let's say we are having a wire of 13 meters or rope of 13 meters length. This is the length of the rope. Now I want to hang it between 2 pegs on the wall. Let's say this is peg A, this is peg B. Now I want to hang it, but the distance between them is less than 13 meters, let's say 8 meters. So when I'm trying to hang this particular rope will take this type of shape. So this type of shape is known as catenary. This catenary problems can be solved in 2 ways. The first way is solving the equation of catenary, in which you will get the catenary like hyperbolic functions. The equation of catenary is equal to y is equal to cos h times of some constant plus c. That is not necessary for us for our JEE Advanced. We need to understand just the concept, how the tension varies with an angle theta, how do we take various terms and everything. So let's see what type of question comes. So all the 5 questions or all the questions that I'm going to deal in this video are taken from Pathfinder. So let's see the first question. This is an easy question. A uniform rope of length 13 meters is tied on a peg A on a wall, passes over a frictionless peg B, fixed in level with the peg A as shown in the figure. Very good, okay. If the equilibrium length of the rope hanging between the pegs is 8 meters, the angle which the rope makes with the wall at the peg A is closest to how much? They are asking you to find this angle theta, if I mention this as theta. Not a tough question. First of all, I need you to understand how does tension vary along this particular rope. Let's forget about this at particular point. This particular point, they are saying this is 8 meters if I'm not wrong, right? So this particular length, the remaining length is 5 meters. This will be somewhere over here. Yes, sir. So if I want the mass of this particular chain, so mg acts downward. M is nothing but lambda, linear mass density into length, that is 5 into g. This is balanced by the tension over here. We got the value of tension, that is 5 lambda g. Let's keep this value aside for some time, and then now it's our time to see this particular portion. This is the portion of the rope, right? Now if I take vertical somewhere over here, okay, these are the verticals we are having, and this is the tension, right? This is tension T, this is also tension T, this is theta, so this also becomes theta if you observe carefully. So now if this is tension, this is T cos theta, and this is also T cos theta, because if it's theta, this will also become theta. So T cos theta, and this is T cos theta. Now this is balanced by the force, that is m into g. So lambda into length is 8 meters, right? 8 into g. So 2t cos theta is equal to 8 times of lambda into g, right? Now we already got the value of t, that is 5 lambda g. So 2 times of 5 lambda g into cos theta is equal to 8 lambda g. So lambda g gets cancelled. So cos theta is equal to 8 by 10, that is 4 by 5. So if cos theta is equal to 8 by 10, what is the value of theta, bacho? You got the point. Theta is equal to 37. So the value of theta they are asking is nothing but 37. Now you may ask me why this is theta. So just extend this and then draw a line over here. If this particular portion is theta, I'll draw a line over this particular part. If this is theta, of course this turns to be theta by vertically opposite angle, right? So theta is equal to 37 degrees is the final answer. So this is our first question. Let's see the second question. So the second question states, this is also from Pathfinder, a uniform rope is tied between a nail A on the wall. So this is nail A, okay, and this is nail B, right? The rope, without touching the ground anywhere, assumed a curved shape known as catenary. The tangents at the ends A and B of this catenary makes angle alpha and B with the vertical respectively. Which of the following conclusions can you make? Let's see carefully. So I want you all to understand, so concentrate. This is the shape of the catenary they have mentioned. Okay, I am zooming this for your purpose. Let's take this particular portion. Okay, let's take this particular portion. Let's say this is DL length. So for DL length, if I enlarge it more, here we are having tension T. As I increase the tension, this becomes T plus dt. So let's say here this is theta, but I want you to remember always, see, the horizontal component of the tension in the string or in this particular rope is remaining constant. This is very important equation in catenary. The horizontal force remains constant all over the rope. So this is one of the very important equation that I want you all to remember. From here, I can say T is equal to K times of secant theta. Yes sir, I understood. Very good. Now it's our time to derive the vertical component. See, simple, the change in vertical component, that is nothing but dt times of, like, change in vertical components is t sin theta. So d times of t sin theta is nothing but its mass. It covers, it balances its mass, right? That will be mu into dl into g. Mu is linear mass density, you can take it as lambda also. That is equal to mu into dl into g. If I take t cos theta, so as tension, so t cos theta is equal to k. So t becomes k times of secant theta, right? T becomes a function of secant theta. So if I take k times of secant theta into sin theta, this becomes tan theta is equal to mu times of dl into g. So k times of d tan theta is equal to mu into dl into g. Now you can say, what you can say? If this is alpha, if this is beta, simply you can say alpha is less than beta because of the dependency of tan theta, tan function. So since it's a tan function, as we go on like downward, the value of beta always increases, right? So angle alpha cannot be greater than angle beta. Angle alpha cannot assume a value of 0 degrees. See, this particular question, when I have dealt previously in some batches of some institutes, students like confused at this option. Like, of course, you will also get confused if you think, well, can't I keep this right like this? And then I can say this is alpha is equal to 0 and then beta is 90. It's possible. But we are talking about catenary. If you keep this like this, the idea of catenary itself spoils, right? So of course angle alpha cannot assume a value of 0 degrees. So this is right. Vertical component of, horizontal component of tension is uniform. Vertical component of tensile force increases with height. There is no dependency of height here in vertical components. There is dt sin theta which is constant over, right? So we can't say that option is true. So option A and C are true. Let's go to the next question. Yeah. Before solving this particular question, let's solve this particular paragraph. Lower end of a uniformly inextensible rope of mass 2 kg and length 4 meters is attached to a block of mass 7.5 kg. They are saying this is mass 7.5 kg and then Coefficient of friction between the block and floor is 0.5. They have mentioned mu is equal to 0.5. Okay. The upper end of the rope is held 2 meters above the lower end so that the tangent at the lower end remains horizontal as shown in the figure. At the lower end, it remains horizontal as shown in the figure. This is a typo error. So the block stands still on the floor. Acceleration due to gravity is 10 meter per second square. The upper end must be pulled at an angle closest to how much? The frictional force between the block and the floor is closest to how much? And then the upper end of the rope is slowly shifted towards downward and simultaneously away from the block, maintaining the tangent at lower end horizontal. When the block begins sliding, at what height above the lower end is the upper end? I want you to solve this particular portion because now I'm going to teach you A and B. Let's see. Simple. This is the part, right? Okay. So see this block only. Okay. This is T. Right. If I bring like this is almost T. We should assume T cos theta is equal to K. So if I take theta is almost 0, this becomes K. And then this is the frictional force which balances it. So frictional force becomes K. Now our task is to find K and theta first. So we know that T is equal to K times of secant theta, and then we found what? D times of K tan theta is equal to mu times of dl into g. So we have y like the distance also here. So if I take some particular portion like this particular portion dl, so let's say this is dl, okay, let's say this is dx, let's say this is dy. So dy, and let's say theta is this one, so this is dl. So let's forget about this for some particular time. Let's solve this. K times of d tan theta is secant square, K times of secant square d theta is equal to mu into dl into g. So what is integral secant square theta d theta? That is tan theta. So K times of tan theta is equal to mu into L into G. We have completed this. So we require two equations because here we have two unknowns. Let's keep this aside for some time. K tan theta is equal to mu into L into G. Now let's see this particular portion. Okay. Now d times of K tan theta I am trying to solve. Okay. D times of K tan theta or K times of integral secant square theta or else K times of d tan theta secant square theta d theta is equal to mu times of, can I write dl as dy cosecant theta into d theta. So let's remove this for some time. Let's remove the integral for some time. We are talking about this portion only, right? So K times of secant square theta into d theta is mu into dy into cosecant theta d theta. Now d theta or cosecant theta, right? This is cosecant theta. Now if I want here K times of secant square theta, secant theta into secant theta by cosecant theta, that will be tan theta into d theta is equal to mu times of dy, right? If I integrate this, initial angle is 0, let's say final angle becomes theta naught. Here initial is 0, finally it is becoming y naught. So K times of secant theta tan theta is secant theta. So secant times of theta naught minus secant 0 is 1, right, is equal to mu times of y naught. This is the second equation we have. Now using equation 1 and equation 2, let's say this is equation 1, let's say this is equation 2, we need to solve. So let's see. Let's see, we know that k tan theta times of mu lg. So L is nothing but, how much is it mentioned? L is length 4 meters, and then y naught is nothing but it's 2 meters, right? And then mass is 7.5 kg, so mu becomes 7.5 by 4 m by L, right? Mu is equal to 7.5 by 4. If I write this, so 75 by 40. So furthermore, if I cancel 5 table, it goes 15 times by 8, right? We got the value of mu. So k times of tan theta is equal to mu. Let's write it as mu into L into G. So don't forget this, we have G here also, right? Here we have G, mu times of y naught into G. So is equal to mu Lg, and then I'm dividing with k times of secant theta minus 1 by mu times of y naught into G. So mu gets cancelled, G gets cancelled, k gets cancelled. So from here we get tan theta by secant theta minus 1 is nothing but L is 4 meters and then y naught is 2 meters. Here we get 2. So from here tan theta is equal to 2 secant theta minus 2. So if I do this, what can I have? Like for suppose tan theta converted as sin theta by cos theta is equal to 2 by cos theta minus 2. So if I want to cancel cos theta, sin theta is equal to 2 minus 2 cos theta, right? If you solve this, sin theta plus 2 cos theta is equal to 2, right? So you can convert sin theta and you can square it and then you can do. So if you find the equation of theta, it becomes 53 degrees. If you solve it and then find, it becomes 53 degrees. If I substitute here, k becomes 15. You can solve this. This is not a tough one. I guess you already know how to solve this. If sin theta plus 2 cos theta is equal to 2, I can write it as sin theta plus cos theta. So sin square theta plus cos square theta is 1 plus cos square theta plus 2 times of cos theta into sin theta plus cos theta. So sin 2 theta comes, and then you can solve like that, and you have simplified versions also. You can do your own calculation. I have found students doing it in much more easier way than I do. So it's your wish. Calculation is completely dependent on you. I prefer this one. Okay. So why I'm doing this is, if you are not making any mistake and then if you are continuing the calculation, you can bring the answer from anywhere. So if you solve this, you get theta is equal to 53, and then if you submit it, you will get k is equal to 15. I'm going to leave it to you. Please do send me the written solution of your solving in the Telegram channel. So simply I said it's 53 degrees above horizontal. We have completed this. This is 53. And then this is frictional force is close to 15 Newton. Now this is HW. Read this and do this. Okay, this is interesting. Now simple. We have two equations. If they are asking you to find, okay, even they are giving you x and they have given you the height at which they have hanged it. Now try to have two equations, mu L into G and k times of secant theta naught minus 1 is equal to mu y naught into G. I want you all to store this in your mind. And then you can do it in multiple ways. Tan theta by secant theta minus 1 is equal to L is 4, y naught is 2. So 2 secant theta minus 2. Secant theta you can write like this. Cos theta will cancel. So sin theta is equal to 2 minus 2 cos theta. Let's see. Like you can also do option verification also. If I take theta is equal to 53, what happens here beta? 2 sin 53 is 4 by 5. Plus this becomes 2 times of cos 53. 3 by 5. So if I do this, 10 by 5, that is 2. Verified. So the angle should be 53 of course. So option verification also can be one of the method. But if they are asking you like an angle theta in numericals, you need to solve it. So friction force between the block and the floor is closest to 15 Newton. As I already said you, the value of friction force in the initial condition will become K. Now see, there is a change. The upper end of the rope is now slowly shifted downwards and simultaneously away from the block, maintaining the tangent at lower end horizontal. When the block begins sliding, at what height above the lower end is the upper end? They're asking you to find why not, and they have given you the various conditions. So try this and then send me the solutions in the Telegram channel. If you are unable to do that, again I'll post the written solution in the Telegram channel.